In this lesson you will learn how to find the volume of a solid using the disk method. This method is used when you have a series of circular disks that are stacked up to find the volume of a solid. So vertical disks are used whenever your disks are in this direction. And you can think of a disk as just a circle. So when your disk is in this direction, you integrate with respect to x. You take pi times the radius function squared, which is really just the area of a circle, and integrate from a to b. A represents the leftmost x value, and b represents the rightmost x value. Horizontal disks are used when your circles are horizontal. The formula is the same except you're integrating with respect to y. The c represents the bottom y value and the d represents the top y value. So let's look at some examples. For number 1, find the volume of the solid generated by revolving the region bounded by y equals square root of x, 0 is less than or equal to x is less than or equal to 4, and the x-axis about the x-axis. So let's take the first equation, y equals the square root of x. If I draw the square root of x in quadrant 1, and then 0 is less than or equal to x is less than 4, these are two lines, one at x equals 0 and the other at x equals 4. So if x is between 0 and 4, it is the region between these two lines, and the x-axis is just the line y equals 0. So the region formed by these four equations is shown right here. If I want to revolve this region where it says about the x-axis, then you want to picture this region being revolved around the x-axis and forming a shape that looks like this. And to find the volume of this, you want to picture a series of vertical disks that are stacked up and their areas are added together to find the volume. So since these disks are vertical, I'm going to integrate with respect to x. So it's the integral from a to b of pi times the radius squared dx. So to find the radius, I want to take the length from here to here. And since I'm integrating with respect to x, I want to take the top curve minus the bottom curve. Well, the top curve is just the square root of x. The bottom curve is the x-axis. So therefore, the radius is equal to the square root of x minus 0, it's always top minus bottom, which is just the square root of x. So when I substitute this in, I have pi times the radius squared, which is the square root of x squared dx. The limits of integration are from the leftmost x value to the rightmost x value. So the furthest x value on the left is 0, and the furthest on the right is 4. So therefore, we're going to integrate from 0 to 4. So the integral from 0 to 4, if I square the square root of x, I just get x. And if I integrate this, pi is just a constant, so it's pi x squared over 2 from 4 to 0. and I can take pi on the outside and just substitute 4 and then 0 and subtract their values. And I get pi times 8, so the volume is equal to 8 pi. For number 2, find the volume of the solid generated by revolving the region bounded by y equals the square root of x and the lines x equals 1 and x equals 4 about the line y equals 1. So this one is similar to number 1. Y equals square root of x, looks like this. X equals 1 is right here, and then x equals 4. So I want to revolve this region about the line y equals 1. So I'm going to draw the line y equals 1 in blue. So this blue line is y equals 1. And I want to take this region and revolve it around this blue line. And when I do that, it looks like this. So if I take a series of circular disks, they are vertical. So since they're vertical, I will integrate with respect to x. So it's the integral from a to b of pi times the radius squared dx. And to find the radius is measured from the top curve to the center of each circle. The top curve is the square root of x. The bottom curve is just the line y equals 1. So the radius is equal to the square root of x minus 1. So when I substitute that into the integral, I have pi times the square root of x minus 1, and I have to square this. And to find the limits of integration, the x value furthest to the left is the point x equals 1, and the x coordinate furthest to the right is x equals 4. So I will integrate from 1 to 4. So to square the square root of x minus 1, I want to write this out as 2 factors. And if I FOIL this, the square root of x times the square root of x is x minus the square root of x minus the square root of x plus 1. And if I combine the like terms, I have x minus 2 square root of x plus 1. And if I rewrite this as x minus 2x to the 1/2 plus 1 dx, I am now ready to integrate. So pi is just a constant, so I'm going to leave that on the outside and integrate this inside quantity. So I have x squared over 2 minus 2x, and then I add 1 to 1/2 is 3/2, and divide it by 3/2, plus x, and I want to integrate this from 4 to 1. So I'm going to rewrite this as pi times x squared over 2 minus, now 2 divided by 3/2 is the same as 2 times 2/3, which is 4/3, x to the 3/2 plus x. So now I'm ready to substitute in 4 and then 1 and subtract their values. So when I put in 4, I have 4 squared over 2 minus 4/3 times, if I take 4 and raise it to the 3/2, 4 to the 3/2 means the square root of 4, which is 2, raised to the third, which is 8. So I'll be taking 4/3 times 8, so that's the first group of parentheses, and then minus, when I substitute 1 in for x, I have 1/2 minus 4/3, and when I take 1 raise it to the 3/2, the square root of 1 is 1, cubed is also 1, so it's times 1 plus 1. So I have pi times 16 over 2 is 8 minus 32 over 3 plus 4, and then I'll distribute that negative, minus 1/2 plus 4/3 minus 1, and 8 plus 4 is 12, minus 1 is 11, negative 32/3 plus 4/3 is negative 28/3, and then minus 1/2, and if I take 11 and write it over 1 and find the least common denominator, which is 6, I'm going to multiply the first fraction by 6, the second one by 2, the third one by 3, so that I have pi times 66 minus 56 minus 3 over 6 is equal to 7 over 6 pi, which is the same as 7 pi over 6. For number 3, the region between the curve x equals 2 over y, 1 is less than or equal to y is less than or equal to 4, and the y-axis is revolved about the y-axis to generate a solid. Find the volume. So let's start with x equals 2 over y. If I write the equation x equals 2 over y, and if you have to graph this, you want to solve for y. So I'm going to take x, write it over 1, and cross multiply. So that I have x times y is equal to 2. And then to solve for y, I divide by x, and I have y equals 2 over x. So 2 over x looks like this, and it's drawn in quadrants 1 and 3. If it were negative 2 over x, I would have drawn it in quadrants 2 and 4. And then I have to draw 1 is less than or equal to y is less than or equal to 4. So I go to the y-axis at 1, draw a horizontal line, and then the y-axis at 4, draw another horizontal line, and the y-axis is just this line, x equals 0. So the region that will be revolved around the y-axis is this region right here. So you want to picture this region right here revolved around the y-axis, and when it does, it will generate a solid that looks like this. And to find the volume, I find the series of circular disks and add them together. And you can see that these disks are now horizontal. So this time I'm going to integrate with respect to y. So I'm still going to find my radius the same way, but I'm just looking at it horizontally. So the radius is found by taking this length to the center of each circle, so the radius is found by taking this length. The radius is just half the diameter, and even though my circles and my graph is not drawn perfect, you can see that the y-axis is the line that's in the center. So to find the radius, instead of taking top minus bottom, when you're integrating with respect to y, it's right minus left. So the curve on the right is the equation x equals 2 over y. I want to use this equation because I'm integrating with respect to y. So it's 2 over y minus the y-axis, which is just x equals 0. So when I take the radius and substitute it in, I just have to put in 2 over y, but I have to square it and integrate with respect to y. And to find c and d, c represents the y coordinate on the bottom. So this point here is the point 0, 1. So the y coordinate is 1. And it goes up to this point here, which is the point 0, 4. The y coordinate is 4, so the integral goes from 1 to 4. So before I integrate this, I first want to square the radius and write that as pi times 4 over y squared. And then I want to bring the y squared up to the numerator by writing this as 4 pi times y to the negative 2. And now I'm ready to integrate. So 4 pi is just a constant, so I'm going to multiply it by adding 1 to the power, which is negative 1, and dividing by negative 1, so that I have negative 4 pi over y, and we'll integrate this from 4 to 1. So I have negative 4 pi, and when we substitute 4 in, it's really 1/4 minus 1 over 1. So I'm going to find the least common denominator, which is 4, and multiply the second fraction by 4 so that I have negative 4 pi, 1 minus 4 over 4, which is negative 4 pi times negative 3 over 4, which is equal to 3 pi.